Hi, welcome to the Quantum Guru. My name is Brajesh Kumar Chaudhary, and this video I am going to discuss question number 1.60 of Irodov, and this question states the arrangement in the figure, the masses are M1, M1, M0, M1 and M2. The masses of the pulley and threads are negligible. There is no friction in the pulley. Find the acceleration W, acceleration vector W with which the body M0 comes down, and the tension of the thread binding together the bodies M1, M2. If coefficient of friction between the bodies and the horizontal surface is equal to K, and consider following cases, consider possible cases. So this is the diagram of the question. Pulley is smooth, massless. So what does that mean? That means the tension on the both side of the string, both side of the pulley would be the same. So we have to see whether the system will move or not. So if we look at the system as a whole, so the pulling force, the downward force is the magnitude of downward force is m0g, and there would be friction between them. So maximum friction on m1 by this floor, the maximum friction on this would be K into normal reaction, that is K m1g, and the maximum friction here would be K m2g. So this can only move if the m0g is more than the sum of K m1g and K m2g, and in that case it will move. If these together are greater than m0g, then the whole system will be at rest. So assuming that m0g is more than K bracket m1 plus m2g, then the motion will start, and this will go down, and according to string constant, the string is inextensible, so magnitude of acceleration of all the bodies will be the same. So this acceleration is suppose w, this acceleration is also w, and this acceleration is also w in the magnitude. We can get answer directly by taking the whole system along the length, but if you want to do in the parts, so assuming that this string, the blue color string, has a tension T1, so I am drawing FBD of M0. So there is a tension T1. I want to apply F net is equal to MF for this body. So F net is equal to net force. We always take in the direction of that direction, we take positive, along which body is accelerating. So downward direction is positive here. So for the body m0g, the equation of motion is m0g minus t1 is equal to m0 into w, that is its acceleration. That is first equation. And suppose tension in this string is T2. So if we draw the FBD of m1, the weight and normal reaction will balance, and the motion is going only along the horizontal direction. So from the string, blue color string, this is pulling it with a tension T1, and green color string is pulling it with tension T2. So again writing F net is equal to mass times acceleration, and when we do that, this one net I want to raise it a little bit more. And when we do that, we take that direction positive in which body is accelerating, so right side direction is positive. So F net is T1 minus T2 minus K m1g is equal to mass times acceleration, that is m1w, second equation. And similarly, we draw the FBD of m2. The pulling force here is T2 by the green color string, and opposing force is a friction, weight normal again balancing each other. So here equation will be T2 minus K m2g is equal to m2 into w. This is the third equation. So we want to add all these three equations. So this minus T1 plus T1 will get cancelled, minus T2 plus T2 will get cancelled. So adding them all, we will get m0 minus K m1 plus m2, and this whole thing multiplied by g, and from this side we will get m0 plus m1 plus m2 multiplied by w. So w is equal to m0 minus k m1 plus m2 g G is outside the bracket, and divide by total mass of the system, which is m0 plus m1 plus m2. But in this question we have to write acceleration in the vector form. So suppose as w is the acceleration, so obviously this is the acceleration vector, and we know that g vector is in the downward direction. So direction of w vector is in the same direction as that of g. So if I write this equation in a vector form, so I will put a vector here and I will put a vector here. By doing that, magnitude has not changed, but I can show that this direction same as in the direction of g vector. So this is answer of acceleration of the body going down, m0 in a vector form. There is one more part there asked, and we have to find the tension of the bodies binding m1 and m2, that is the green color string. So that tension is T2. So from here I can just put the value of w, will get T2. So from equation 3 I can write T2 is equal to m2 w plus that will go on that side, will become k m2 into g. So m2 we can take common, so that will be w plus kg, and I will put the numerical value of w. So w I will put from here, which is m0 minus k m1 plus m2, and divide by m0 plus m1 plus m2. G is there and G is there, so I will take G outside, so plus K into G. So let me simplify this thing. This is m2, and here I can take the whole m0 plus m1 plus m2 denominator. When I will multiply this thing, there will be m1 plus m2 into k, and this minus k m1 plus m2 will get cancelled. So what I will remain with, m0 plus this m0 into k. So we can take m0 common, and that will be 1 plus k, and this thing is multiplied by g, or I can simply write my answer as m0 1 plus k multiplied by m2 into g. So this is a tension connecting these two bodies. That is our answer. Thank you.